Hi, it's time for another math easy solution. Here to discuss further into infinite limits, vertical asymptotes, and now look at some examples to illustrate this, which I went over in my earlier video, so make sure to watch that in the video link below. Basically, the examples I'm going to go over is these three right here, and let's look at the first one, which is limit as x approaches 0 of 1 divided by x squared. Yes, if I just write that function down right here. So now the idea of this one is you can see you can't divide by 0, so you can't just plug it in. But as you can see, if you go from the right or the left side of 0, then basically you were basically right here, if you were to graph it out as you're approaching 0 right here, doesn't matter which side because you're going to be squaring it, so it's going to be positive wherever you go. So when you have, let's say, 0.01 or something, 1 divided by this means this can go in it a lot of times, so it's going to get higher and higher. So as you approach 0, where just 1 divided by 0 can go infinite times, so it's just going to go up like this. So basically it's going to go up all the way like that. And then from my earlier video on vertical asymptotes, this x equals 0 is a vertical asymptote. Yeah, it's a vertical asymptote, and basically the limit right here is going to equal to infinity. And it's positive infinity because you can see from the graph is going up. So now if we look at the second example right here, basically this is a two-part one. Basically find the limit as x approaches 3 from this plus side or from the right side of 2x divided by x minus 3, and also from the left side or the negative side. This is a convention for going from the left side of it. So if we look at this number 2 again, if you just look at from the right side of the 3 plus right here, so as you can see in this one here, you can't divide by 0, and this is 0 when you have basically x minus 3 is equal to 0, or x is equal to 3 right here. So if we're approaching from the right side of 3, example, let's say 3.00, let's get really close to 3.001 minus 3, etc. This just equals to, well, 0.0001, and this is a plus. So that's all I wanted to get to, is this is a plus. You're dividing by a small number, so you're going to get a large number right here. So then this one would just equal to, well, positive infinity right here. Because right here you're going to have 2 times x, which is going to be, let's say, a positive number divided by a positive number. So you're going to have positive numbers really, really small, so you can go to infinity. So now if we look at approaching from the left side of it, again, once again, if we go to x equals 3, that's where it's going to be not defined, or it's going to go to infinity. But now since we're the left side of 3, so we're going to have something like 2.999, etc. minus 3. Now this is equals to now negative 0.0001. So just an example, and I just want to illustrate again, is this negative sign. So you're going to have, this one's going to be a positive number, 2 times, let's say 2.999, divided by, well, negative 0.001. It's going to go really, really large, but negative, because there's a negative right here. So you're going to, this equals to negative infinity. And here I've graphed this using Google, this function 2x divided by x minus 3. And as you can see, it's if we have this asymptote right here, we have one at the x equals 3 line. Now here I just drew that part right here. So this is x equals to 3 right here. And as you can see, it's going to, as you're approaching from the left side, you're going to negative infinity. And as you're approaching from the right side of 3, you're going to, well, plus infinity. Exactly what we just found out above here. And now the last example I want to go over is basically find a vertical asymptotes of these two functions, tan x and ln of x. So if we look at this function fx equals tan of x, remember this is defined as sine of x divided by cos of x right here. You can see more on this in my video link below on trigonometry. Basically, so you have something like this, and so this is not defined whenever cos of x is equal to 0. And if we were to basically draw cos of x right here, the graph, so it's equal to 0 whenever this is, this point right here, this is actually pi over 2, and then this one right here is pi, so you have negative pi over 2 right here, and then this is separated from here to here by a full pi, or this is going to be 3 pi over 2, so the difference between here and here is pi. Yeah, as well as here and here is pi. See more on the cosine video in my video link below on trigonometry, basically. So again, this difference between pi, so of pi between these 0 points. Yeah, so if we were to write this down, basically cos of x is equal to 0 whenever we have x equal to plus or minus pi over 2. And if you go to this side, there's always an opposite one as well, so plus or minus 3 pi over 2, and then plus or minus, well, it's always going to be odd number, 5 pi over 2, etc. It goes 7, etc. And thus, these are vertical asymptotes right here. Yeah, now these are vertical asymptotes, and we've found basically our answer. But to see how these behave, these depend, like whether it's going to be in positive or negative infinity. This depends on the sine and cos function at the same time. So if we look at the sine one, it's going to look something like this. Yeah, so if we draw this one is the sine curve right here. And as you can see, when we look at the asymptotes where it's the zeros of the cosine curve, so if we look left of them, this side is going to be positive on the sine, positive on this one, so it's going to be positive going upwards initially. Then down here we're going to have a positive sine divided by a negative cosine, so it's going to go downwards in this case. So this one's up and down. Now if we look at this one as well, again, now this one from the left of it, we're going to have a negative, this one's cos, negative sine, so negative divided by negative is positive, so it's going to go upwards, and this one's going to be positive, negative, and this is going to go downwards right here, because that's yeah, that one's going to be like that. And it's similar to this case here, so it's always to the left of the asymptote. If we look at this one right here, it's going to be negative, negative, it's going to go up. Then on the right side, it's going to be positive, negative, it's going to go down, because it's negative, positive divided by negative, or negative divided by positive, doesn't matter. It's going to be going downwards right here. So to the left of it, yeah, so to the left of the vertical asymptote, it's going to go upwards, and then to the right of it is always going to go downwards right here. And if I here, like here I graphed it with Google, and you see the same thing right here. This is pi over 2, because remember 3.14 is pi, so pi is going to be somewhere like, yeah, pi over 2 is going to be something like 1.57, so it's going to be somewhere around like this part right here. Yeah, and this one is pi over 2, and as you can see, it's always going to the left of it. It's going to go up and downward. It's going to go to the bottom right here. And similarly, this is every single pi, or 3.14. So we shift it down over to here, or somewhere close to that as well. So it's periodical, and it keeps going like that. Now, to get an idea of the vertical asymptote for this function at y or fx equals to ln of x, let's just write it as equal to y right here. So this is the inverse. Remember in my earlier video on inverse functions, this just means if you have e to the y of a equals to x right here, then this inverse is just going to be finding this variable now, y equals to ln x. And the inverse of exponential function is called this natural log right here. See more on this in the video link below. So basically, now with this function, the peculiar thing about this one's always positive, because if e to, or any number to the power of anything, it's always going to be positive. Any power function is positive. So now, so if you wanted to get, so if it's positive, basically if you were to go as, let's say in this case right here, if you have y approach infinity, then x is going to approach infinity, if this is how the function is. But since it's positive, the lowest it can get is 0. It can approach 0, because if you approach y to negative infinity, then you're just gonna then x is gonna be approaching, well, this one's gonna approach infinity as well. This is gonna be approaching 0 as the curve of a exponential function. This curve would just look something like this. So it goes up like that. So it's going to infinity. This is e to the x. As you see, it's approaching 0 right here. So now, since it's approaching 0 right here, we could just, when we inverse this, so if we put it inside here, so as x approaches to 0, y is approaching to negative infinity, and this is going to be the inverse, or which is the inverse of ln, so it's going to look something like this. And this is ln of x. As you can see, this is approaching negative infinity right here, so negative infinity. And basically this line right here, x equals to 0, is the vertical asymptote. And I'll just write that down right here. So basically, yeah, that's all for today. Actually, I just wanted to go over this. It's just find out the vertical asymptote. And it's going down like this is the only one here. You can't get any more, you can't go to the left of this because it's not defined there. That's because e to the x is just going to be below 0. It's always positive. So this one's not going to be, so this one's, the x is always greater than 0. So as you can see, that's vertical asymptote. What's all for today? Remember, you can download these notes in the Dropbox link below, and hopefully learn from this, and stay tuned for another math easy solution.